Yes. Good evening, sir or madam. Um, this is Godpile Group, and this is Group 32. Yeah, and we are presenting a project titled Interpretable Machine Learning for Student Performance Prediction in STEM subjects in Ugandan secondary schools. And below are my teammates, the ones we developed the project with. I myself, Wanyama Edgar Francis, we have Mulongo Michael, then we have Ainem Dawazi Shina, and lastly we have Tivesi Badanka.
That
is basically a machine learning project. Michael, you can mute.
Yes, I'm around, but mine was on and off.
You can mute.
Okay.
Yeah. Sorry for that interruption. I was saying this project is basically a machine learning project, and it's based on predicting students' performance in these kinds of subjects, the same subjects. And as I said, below are my teammates, as you see. So through this presentation, I'll be taking you through the introduction, then the problem statement, the related works, the research questions, the objectives, the methodology, then the experimental results, conclusion, then the future research, direction, references, and acknowledgement. When we come to the introduction, we see that interpretable machine learning has highly gained increasing attention in the recent years because it has enabled the development of more transparent and accountable, predictable models. We see that the transparent models we're talking about, these are the kinds of models whereby they are able to produce explanations for the predictions that are made. And we see that interpretable machine learning has the potential to provide valuable insights into the factors that influence student performance. And in particular, this is in STEM subjects, as we said. We see that by using these techniques, the interpretable machine learning techniques, it's possible to identify the key predictors for student performance and inform the interventions to improve outcomes for students. So we explored the use of interpretable machine learning for student performance prediction in STEM subjects in the Uganda schools. And our main goal was to improve access of education and opportunities for students in these subjects. So when you go to the problem statement, we see that the main problem we have been tackling is the lack of interpretable machine learning models for student performance prediction in STEM subjects in Uganda secondary schools. Why is it a problem? We see that there exists traditional methods, and these traditional methods for predicting students' performance, they are not transparent. They don't provide transparent predictions for the performance of students, and they are often subjective and may not accurately predict future success. But however, the use of machine learning in education is still relatively new in Uganda because there are really few schools using such systems, or even one or two. And we see that there is lack of understanding and expertise in this area. That's why we decided to come up with such a project. Yeah, we see when it comes to the research questions, we see that one of the questions, the main question is how effective is the machine learning model at predicting students' performance in STEM subjects in Uganda secondary schools? Then what is the potential impact of using the machine learning model on improving student performance in STEM subjects in Uganda secondary schools? Then what are the challenges and limitations of using interpretable machine learning for student performance prediction in STEM subjects in Uganda secondary schools, and how can they be overcome? Then what is the potential for using interpretable machine learning to support decision-making and intervention planning in the context of STEM education in Ugandan secondary schools? When we come to the research objectives, these are the things that are driving our project to go on. The main objective is to develop and evaluate a machine learning model that can accurately predict student performance in STEM subjects in Ugandan secondary schools. Then the other is to assess the potential impacts of the machine learning model on improving student performance in STEM subjects in Ugandan secondary schools. Then to identify potential challenges and limitations of using interpretable machine learning for student performance prediction in STEM subjects in Ugandan secondary schools. And it suggests ways to overcome them. Then to explore the potential for using interpretable machine learning to support decision making and intervention planning in the context of STEM subjects. So these were our objectives, and we see that you have achieved most of them. Then we see the data set description. We see that in the process of collecting data, we collected data, but the main sources were the various schools where we went, and the other source was an online platform that we used. But we visited various schools, like we gave students questionnaires to fill in and give us the information, the demographic information. Of course, we visited these schools and we sought permission, and the management of those schools gave us the permission to collect data. So we were able to collect it. Then we also collected data from some online platforms. Then after we merged that data, after merging that data, we were able to do what? To form a data set from that merged data. But of course, we did a lot of things. We had to first clean the data. We had to remove the unwanted values that were there. We had to do a lot of computations in that data such that we came up with this data set that you see on the screen. Yeah, through all those computations we made, we were able to come up with a full data set from the various data sources that we got. And you see that the target variable is the average score of the overall performance that has values of each student taken in the same subjects. But our data set had a total of 15 features and 5 urban records, as you see. Yes. So this is basically how our data set looked like. Yes, then when you go to the next thing, when you go to the methodology, sorry for that. Minute. We see that when you go to the methodology, first of all, we collected the data. Like I explained in the data set description, and of course we had to clean it. We had also to transform it, we had to transform the categorical features to the what? Numerical features. Yes, then when it came to model development, of course, we had to first split the data into the training and testing set, of which we use the training set to train the data, to train the model. Then we use the testing set to evaluate the model, to assess the model and see the predictions it is giving us. Yeah, of course, when we're training the model, we trained 2 types of models. We trained a linear regression model and a random forest regression model. Yeah, those are the 2 kinds of algorithms we used. Then we see to evaluate the model. We're able to evaluate the model. Yeah, and we got we used 3 evaluation metrics. We used the R2 score. That was the root. We used the R2 score. Then we used the. Sorry for that. Of course, okay. The main matrix we used was R2 score. Then after that, we had to bring in the interpretability part of the model, whereby we used 2 interpretability techniques. We had LIME and SHARP. Yeah. Then after that, we had to embed our model that we developed in our web application. Yes, we had two models, a linear regression model and a random forest model, but of course we had to evaluate one or two of them to see which one was performing best. And yeah, so we went with the random forest model because it was giving us good predictions. Then of course we had to embed it and after deploy it. Yes. Yeah. So this is basically what we went through as we're training the model. We had to divide the data into the training and testing sets. Yes. Then after we implemented the two types of models, as I said, we had the random forest regression model and the linear regression model. Then of course, these models were trained on the historical data and then we used them to predict the future predictions. Yes. Then of course, after making the predictions and after making the predictions, this is how we graphically came up with a graph that a graph of predicted values over the actual values. So these are the predicted values when you predicted when the model gave us the predictions, these are the predicted values. And on the x-axis, we have the actual values that we had in the data set. Because this overall performance is the dependent feature that we used. It's the feature that depends on all the other features that we saw in the data set. Yes. So when it comes to interpretability, we use two interpretability techniques, whereby we have SHARP and LIME. Yes, and when it comes to SHARP, we made our computations and we came to see that this is what it gave us. And this one clearly explains that this graph explains how these features, all these features affect the prediction, either positively or negatively, and the contributions with which with which impact it has. So we see that physics, term 1, chemistry, term 3, chemistry, term 2, all these performances in these subjects, the scores, they were giving us a positive impact, and we come to see that these other categorical data weren't giving us any impact at all. They were just moderate. Yes, that was SHARP. So when it comes to LIME on linear regression, see that it gave us a prediction of 68.65986761. Yes, and we see that the ones in yellow are the positive, are the ones that have a positive impact, the features. Then the features in blue are the ones that have a negative impact. So that's basically how LIME explained our predictions. Then for the random forest regression model, it had a prediction of 83.076. Yes, whereby most of the features are giving us a positive impact on the model prediction. Yeah, so below are the results of the evaluation. You see that linear regression model on the evaluation metrics, on the 3 evaluation metrics, on root squared, R squared score, mean squared error, and mean absolute error, they had a value of 1.0. Then the random forest regression, we see that this one, the root R squared score, it has 0.8. Then mean squared error had 5.0. Then mean absolute error has 1.7. So we see that this is the best when it comes to random forest regression. See that R squared score is the best. Then when it comes to linear regression, all of them are having the same value. Yeah. Then we see that, in conclusion, we see that it is important to consider interpretability of machine learning models and predicting students' performance, as understanding the factors that contribute to the students' success can help educators and policymakers make informed decisions about how to support and intervene for struggling students. Then the future works are, of course, we plan to expand the scope of our project, not only to the university program, but of course to the real life world, in the education context, the education systems of different countries. We plan to develop such systems for them that predict performance. Then acknowledgement, I thank Almighty God who has kept us alive and has given us knowledge for this research. Really thankful to him. And I would also like to extend my sincere appreciation to our supervisor, Mr. Galiwango. Mr. Galiwango. Yes, his tireless efforts that he has put in to ensure that we produce such good work. I beg to end from here. Thank you so much.